Hi, mathletes. Today we're going to investigate maximum area. So let's draw all the possible rectangles that have a perimeter of 24 centimeters. We're only going to use whole numbers. So remember, perimeter is the distance around. So in this case, if this rectangle, the bottom is 11, the top would also be 11, and the left and the right side would both be 1, and the sum is 24. Another one would be 10 centimeters by 2 centimeters, 9 centimeters by 3 centimeters, 8 centimeters by 4 centimeters, 7 centimeters by 5 centimeters, and the last one is 6 centimeters by 6 centimeters. Now let's put them into a table. So here's my first shape. Again, it's 11 centimeters by 1 centimeter, and we're going to calculate the area. And a reminder that the area is the base multiplied by the height, so 11 multiplied by 1 is 11 squared centimeters. For the next one, it was 10 centimeters by 2 centimeters, and the product of 10 and 2 is 20, so 20 squared centimeters. For the third one, it was 9 centimeters by 3 centimeters, and the product 27 squared centimeters. The fourth one was 8 centimeters by 4 centimeters, so the product is 32 squared centimeters. The next one was 7 centimeters by 5 centimeters, and the product being 35 squared centimeters. And the last one, the red one, is 6 centimeters by 6 centimeters, and the product is 36 squared centimeters. So looking at this table, what do you see? What do you think? And what do you wonder? You might want to pause the video here. So what dimensions of a rectangle will give the maximum area if the perimeter is 40 meters? Well, looking back at this table, I noticed that the maximum area, which was 36 squared centimeters in this investigation, is when the length and the width were the same. So in order to find the maximum area of the perimeter that's 40 meters, well, I know that it's when all the sides are equal. I also know that a rectangle has 4 sides, so I will divide the perimeter then by 4. So 40 divided by 4 is 10. So that means that the dimensions would be a square with each side a length of 10 meters. Well, what about if I have a rectangle and I want to find the maximum area if the perimeter is 15 centimeters? Again, it's when all the sides are equal. So since the rectangle has 4 sides, I divide the perimeter by 4. So 15 divided by 4 is 3 7/500ths. So the dimensions are going to be a square with a length of 3 7/500 centimeters. Now, what if I want to find the largest area that can be enclosed by the rectangle that has a perimeter of 12? Okay, so I don't want to just know the sides, I want to know the area. So I know that the maximum area is when all the sides again are equal. So I know that a rectangle has 4 sides. So I divide this perimeter by 4. So 12 divided by 4 is 3. Now I want to find the area, and I know that this is going to be a square. And so finding the area of a squared is s squared, where s is the length of the side. We know that the side is 3, so 3 squared is 9. So the largest area would be 9 squared meters. Let's try another one. This time we want the largest area by a rectangle with a perimeter of 10 centimeters. We're going to solve it the same way. So again, maximum area, all the sides are equal. We know the rectangle has 4 sides, so we divide it by 4. So the perimeter, which is 100, divided by 4 is 25. That means each side of the square is 25. And the area of a square is s squared, so 25 squared is 625. So the largest area would be 625 squared meters. Based on this investigation, can you make a conjecture or a rule about the maximum area of a rectangle? Well, the maximum area of a rectangle is when the length and the height are equal, meaning all the sides are equal. In other words, it's a square. So now let's do another investigation. This time we're going to look at an isosceles triangle. And remember, an isosceles triangle means that 2 sides are the same length. Just like with the rectangles, we're only going to use whole numbers, and we're also going to use a perimeter of 24 centimeters. So here's the first one. It's a rather tall one. Each side is 11, and the base is 2. So 11 plus 11 plus 2 add up to 24 centimeters. Another one I have is the base is 4 with the sides of 10, the base of 6 with the sides of 9, the base of 8 with the sides also 8, and a base of 10 with the sides of 7. Did you notice that? My bases are all even, 2, 4, 6, 8, 10. But why does my base have to be even? Well, let's try creating an isosceles triangle with a base of 5 centimeters. So there's my 5 centimeters as the base. Now I know that these two sides have to be equal. So I'm going to say the perimeter is 24 minus 5 is 19. Again, since they have to be the same, I divide it by 2, and I end up with 9.5 as the lengths of both of my sides. But remember, for this investigation, I only wanted whole numbers. So that's why we have to use an even number as a base. I also noticed that the biggest base I had was 10 centimeters. Can you draw a triangle with a base that's greater than 10 centimeters? Give it a try, and we'll come back to that at the end of the video, so stay tuned. So just like we did with the rectangles, let's make a table with the possible isosceles triangles. So here's my shape. For this one, we have the base is 2 and the lengths of the sides was 11. And now we're going to calculate the area. So here we go. This is the height and this is the base. Remember, to find the area of a triangle, it's half the base multiplied by the height. But I don't know the height. So in order to calculate the height, I need to use the Pythagorean theorem, which is a squared plus b squared equals c squared. The Pythagorean theorem, remember, is used in right triangles. So here's my right angle right here. So I'm going to show you this a little bit easier. So there is my right triangle. So again, when we're looking at this, we need to divide this base by 2 because I'm using half. This is cutting it in half. Okay, so now my base is 1 instead of 2 centimeters. So this is my a squared, 1. My b squared is the height, which is what I'm trying to figure out. And my c squared is the hypotenuse. Remember, the hypotenuse is always that side that's across from your right angle. It's also the longest side in your right triangles, which is 11 squared. So 1 squared is 1 plus b squared equals 11 squared is 121. So b squared is 120. We find the square root. And so b is about 10 and 9,500 centimeters. So that's going to be my height. Now to calculate the area, remember it's half the base multiplied by the height. And again, we're looking at this green triangle here. So 1/2, the base is 2, and the height is 10 and 9,500 hundredths. And when we calculate it, it actually is 10 and 9,500 hundredths squared centimeters. So we can put that in our table. The next one is our orange one, which the base was 4 and the length of the side is 10. I calculated the height and then the area. I'm not going to go into detail on this, but again, you can pause the video if you want to look at it in more detail. For the purple one, the 6x9, again, calculated the height and the area, and feel free to pause the video to look at that in more detail. The blue one, 8x8, the height and the area. And the last one is the red one, the 10x7. I calculated the height and the area. All right, so again, looking at this table, now what do you see, think, and wonder? And you can compare that to what you were seeing and thinking and wondering about the table with the rectangles as well. Again, feel free to pause. So what length should the sides of a triangle be to obtain the maximum area if the perimeter is 60 centimeters? Well, looking back at this, I noticed here that the biggest area was 27.72 squared centimeters. And I noticed that the length of the base and the length of the sides were the same. So all of them were the same. In other words, it was an equilateral triangle. So the maximum area is when all the sides are equal. So since a triangle has 3 sides, I can divide the perimeter then by 3. So 60 divided by 3 is 20. So the dimensions are an equilateral triangle with each side a length of 20 centimeters. Well, what length should the sides of a triangle be to obtain the maximum area if the perimeter is 13.5 meters? Again, the maximum area is when all the sides are equal. The triangle has 3 sides, so we're going to divide the perimeter by 3. So 13.5 divided by 3 is 4.5. So the dimensions are an equilateral triangle with each side being 4.5 meters. So based on this investigation, can you make a conjecture or a rule about the maximum area of a triangle? Well, the maximum area of a triangle is also when all the sides are equal, just like with the quadrilateral when all the sides are equal. So can you make a conjecture about the maximum area of any polygon? Well, the maximum area of any polygon would be when all of the sides are equal, no matter how many sides it has. So remember earlier in the video where I was asking if you wanted to try to draw a triangle with a base that was greater than 10 centimeters? Did you give it a go? What happened? Well, here's what happened when I tried. I said, okay, let's try a base of 12 because again, we were just using even numbers. And I thought, well, it went 2, 4, 6, 8, 10. So 12 would be next. So there's my base of 12. And I noticed that if it's 12 and I need the perimeter of 24, that means that each side needs to be 6 because 12 plus 6 plus 6 equals 24. So I drew each side of 6 and that's what it looked like. So you cannot make a triangle. Those two lines, these two they don't come together to a vertex. So it's impossible. So the biggest base that I can have is 10. I hope you had fun with this investigation and now you know a little bit more about finding the maximum area of any type of polygon. Thank you so much for watching.